problems. Let's I'll tell you what. Let's do number. I don't care.
8.
7 through 12. All right. We did 8 in the last class. Was that all right?
Oh, 10.
Because you could always go back to that other
Yeah,
video,
let's do
to the other class and look
10.
at it. 10. Okay. All right, that's fine. So it says right. Did I do 10? Maybe we did 10 too. That's okay. I'll still do 10. It says a right triangle JKL. Now watch. What I would do. Let me get my pen marker here. Oops, let me do this. I'm sorry. There we go. That's what I want. Let's just make this a little bit smaller. It says a right triangle. So if you're going to do a right triangle, it'll look probably something like this. Now I'm just doing a rough sketch right now just to get an idea of what I'm going to make it look like over here. Okay. So I'm looking at number 10. It says right triangle JKL with legs JK and this is a different one with legs JK and KL. So JK and KL. So that the K would go here then, wouldn't it? Because these are the two legs, aren't they? Because that's the hypotenuse. So JK and KL, that would be one leg. KL would be the other leg. Are you with me so far? All right. So it does matter where you put those letters, correct? And then so that JK, this one right here, is A units long. So the length of that is A. And it says leg KL right here is 4B units long.
I put the J with the L and the L with the J's.
That's what I did.
Yeah, you could do that. Okay. That would be okay. Yeah, you could switch the J and the L.
Right.
But the K has to go here, though.
Oh, yeah.
Yep, the K has to go here. You could switch the J and the L, and that would be fine as well.
Okay.
All right. So if I was going to do this real nice and proper, I would I'd put it right here. All right. So now, just because this is 4B, does that mean it's 4 times as long as this?
No.
Not necessarily, because it's 4 times B. I have no idea how long B is, do I? So you just make up a distance, for that. Make up a length, and then, but you do know it's a right triangle, correct? So it must look something like that, right? Can you see the red or not? Jane, you want to hit that light just to make it a little easier to see? Can you see it a little bit better now?
A little bit better.
The red? Okay. Yeah, there we go. All right, so there you go. And what we want to do, what does it say? It says position and label each triangle in the coordinate plane. So we have to label them. I can't just put this as A. I have to, when it says label it, I want to know what the vertices are. All right, so that's J, and this is K, and this is L. So I've labeled it, but I want to position it. Now, when when it says position, they want the actual ordered pair of each vertex. You okay with that? And then we'll put that right here. All right, so let's do the easiest one first. K would be the easiest one. What's the ordered pair? 0, 0, okay? Now remember, the length of this is 4B, correct? So what would the ordered pair be right here? It's supposed to be an L. Yeah, 4B, 0. Very good. So it's 4B, 0, because you go over this amount and you go up 0, correct? All right, this one right here. So you go 0, and how far up do you go? Right, because they said JK is A, so it's 0A.
Alright, this isn't that hard.
So, yeah, that was pretty easy, wasn't it?
That was the hardest one there.
That was the hardest one?
My opinion.
Okay. What's that? Give you the answers?
Yeah, just that
Yeah. Let's just do one more of these. Is there one of these? Let's do number
11 or
12. Let's do 12. Yeah. I did number 8 in the other class, so if you really want to look at number 8, you can go on YouTube to the first period class.
Alright.
Who's in it?
Like what period?
A lot of people. Like 10th and 11th, I think.
Some freshmen.
Are there freshmen in there too?
Yeah. Kathleen and Emily and...
Okay.
I
Yeah.
thought
I hardly know who's in what grade anymore, just because
Yeah.
I got a mixture of everybody in it, and it's hard to remember who's in what grade. All right, what do we say we're doing? Number 12.
Number 12.
All right, so let's look at number 12. It says an equilateral triangle DEF with sides 4B units long. Okay, an equilateral triangle. So let's start down here. I always like to start at the vertex and then go along one of the axes. Okay, so it's equilateral, correct? So there's one side. What must be true about the other 3 sides?
It's congruent.
They're the same length as that. Now, I was going to copy and paste, but I'm not going to. Let's just, yeah, let's do that.
I just took a tough time drawing this, but I finally got it because I was trying to make it equal in the ground.
Okay, it's equilateral, correct?
Yeah.
Which means it's also equiangular, right? Because we learned that the other day. And it also means, what's the degree? 60 degrees. Okay, so with my little thing right here, I can actually make it, what do I do? Rotate? Yeah. 60 degrees. And do that. Alright? And so I can... Now, you would just sketch it out, wouldn't you?
Yeah.
Alright. And that's fine. I just, I'm a little... That's what people say, but I hate to say I'm OCD, because I'm really not. Because OCD is a real problem that some people have. I want to reflect. There we go. Alright. So I wouldn't call my condition OCD. I'm just particular. Alright? Don't you think?
Sure.
I'm exact.
Precise.
What's the word?
Perfectionist?
Perfectionist, yeah. I think sometimes. On some things, not everything, but on some things I think I have a little perfectionist kind of part in me. So anyway, we got an equilateral triangle, don't we? And it says the length of all the sides are what? 4b?
Mm-hmm.
Alright, so let's put some ordered pairs in here. So what's that ordered pair right there? 0, 0. What's this one going to be? 4b, 0, correct. And, what about this one right here? That's the one I got to think about a little bit.
It'd be 2b, 2b.
Alright, let's think about that. Now, it would be 2b, because remember we did talk about this the other day. When we have an equilateral triangle or an isosceles triangle, if I drop this straight down, or perpendicular, where's it going to hit?
2b.
It's going to hit at the midpoint, isn't it? Alright, so if the whole length is 4b, then this would be 2b, right? Because half of 4b is 2b. You got it? So, how far over do you go? You go 2b. Now, how far up do you go?
Oh, 4b.
Now, that's what somebody in the other class said. Now, I want to show you something. I just want to show you graphically why it's not 4b. So, let's rotate this 90 degrees. And, okay, now watch. That's 4b. Would you agree? I just copied and pasted. So the length of this one is the same exact length as of the bottom and the sides. Okay. So what I want to do is I want to take this and put it like right here.
Oh, come on.
So look, is the height of it? I'll put it right here.
It's like
Is the height of it?
3.25.
No. Yeah, but we don't know though, do we? Right. So if we don't really know, yeah, you call it something else because we don't know, and there's really actually no way to figure out.
Okay, let me change. 12.
As far as, well, the problem is, well, no, actually you could. Yeah, you're right, you could. Let's do that. I forgot about that. Let's do that. Watch. Are you listening? Come on now. What's going on? Ben, please. Come on, sit up. Pay attention. Okay? We're getting into the meat of this problem right now. You're not even acting like you care. So let's pay attention to this. I want to find the height of this thing. So you're right, we could do Pythagorean Theorem because what's the length of from here to here?
2b.
That's 2b. What's the length from here to here?
4b.
That's 4b, correct? So I could find this height right here, couldn't I? So what would you do? A squared plus b squared. Yeah, so let's call this whatever. Let's call it just a. Is that all right? So that's a squared plus, what's this? Yeah, 2b squared, or not 2b squared, equals what?
4b squared.
4b squared. Actually, that's not quite correct, is it? I can't just square the b. What do I have to square?
Everything.
Right, I got to square the 2 and the b, right? And then I got to square this.
The c is always the hypotenuse,
Alright.
correct? The c squared is always the hypotenuse.
Yes, yes. Okay. So watch what I've got. I got a squared plus what? 4b squared equals 16b squared. Yes? Subtract 4b squared from both sides, so a squared equals 12b squared, correct? Square root both sides,
A.
so a equals... Now let's think of the square root of 12. Did you do this in Algebra 1?
Yeah.
It's the square root of 4 times 3. Do you remember that? Square root of 4 is what? 2 square root of 3. So if I want to simplify it, it's what? It's 2 square root of 3, and then I take the square root of b squared, and I get what? Just b. So that's the height of this. From here to here is what? It's 2 square root of 3b. So what's my ordered pair? I went over 2b, and how far up did I go? 2 square root of 3b. Let's move this. So it's 2 squared. I just made you do it. Look, if I went over it right here, sure, I could expect you to be able to do this. That's not that hard, okay? It's just Pythagorean Theorem. It's really not. Okay, it's a right triangle. I got two sides of a right triangle. You can find that third side by Pythagorean Theorem. I just showed you how to do it. All right, so you go and you practice it, and sure, I could give you something like that. That's not that big of a deal. So what is the ordered pair right here? You go over 2b, and you go up 2 squared of 3b. All right? And that's all that you have to do for that. Record. Okay. All right, so here's our triangle. This is number 19 on page 305. And that's what we just drew, the isosceles triangle, basically. That's all we did so far. So it says the segments joining the base vertices. Well, what's a base vertex? This right here. So a segment joining this point right here to what? To the midpoint of the legs of the isosceles triangle. So let's do a different color just so it stands out a little bit more. So what I'm going to do is I'm going to connect with a segment from this vertex where? To the midpoint of this leg. Does that look about the midpoint? I'm just eyeballing right now. That's pretty close. No.
Oh.
So, all right, that's okay. So we're saying that that's the midpoint right there. Okay with that? And then I got to do another one. It says from the base vertices, which means from both of them. So I'm going to take it from this other vertex and go to the midpoint of the other side. And that looks pretty nice right there. Okay? What I want to do now, look, I could show you how to prove it, and I may, if we have a little bit of time here, I may show you how to actually prove it, but on the test, I'm not going to make you prove it. I'm just going to make you tell where all these points are, okay? Tell me the ordered pairs, okay, the coordinates of these points. So let's go back to red for this point right here. Now we have to think a little bit. Now watch. We're finding midpoints, aren't we? So I could call this whole distance right here A if I wanted to. And that would be fine. You could do that if you wanted to. But I'm going to pick something that makes it a little bit easier. Sure, I could call it 2A. Remember we talked about that yesterday? I could call this whole thing 2A because what am I doing? I'm finding the midpoint. But if you think of it, watch. I'm going to go a step further. I didn't do this in the first class, and I probably should have after I did it. Watch. If I drop a perpendicular straight down, let's not click, please. Thank you. If I drop the perpendicular, where is this right here? Midpoint. This is halfway, isn't it? Yeah. All right. But then, so that's the midpoint of this whole length. But I also have to find
the triple midpoint?
The midpoint of from here to here. So let's not just call this 2A. Yeah, I think it might make it a little easier for us, right? Now, could you have called it just A? Yeah. Absolutely. But I think for us, it might be a little bit easier if we just call it 4A. Does that make sense? Because I'm finding there's the midpoint, and there's the midpoint, so I'm taking half of 4, which is 2, half of 2, which is 1. Okay? All right? Yeah, that would be 4A0 right here, wouldn't it? All right? What about this point up here? Well, how far did we go? We went to where? We went to 2A, didn't we? And then how far up do we go? We don't know. So we're not sure how tall it is. Let's call it B, but instead of just B, we'll call it 4B, just like we did with the 4A. All right, so we'll call that 4B. Make sure I don't go over, okay? So what is this point then? It's 2A, 4B. Now watch. Let's do this in blue again. This point right here, that's the midpoint. Now watch. In order to get this point, what do? I go half of this, which would be where?
The midpoint of
A, right? So halfway between there and there would be A, and then halfway up would be what?
2A.
It would be
4B. 2B.
2B. That's correct, because from here to here is 4B. Here to here would be 2B. So what would this ordered pair be right there? How far did you go over?
A 2B.
2B.
Oh, yeah.
See that? What about this point right here?
Got a 3A.
Well, let's think about this. This is halfway between here and here would be
3A, 2B.
A, right? But this is 1A, 2A. This would be 3A, wouldn't it? So that's 3A. And how far up?
2B.
2B. And there you go.
You got 30 seconds.
Right? And there's your points. That's what I'm going to ask for on the test.
Oh, that's easy.
Okay? I'm not going to ask you to prove it, but just for fun, on the next video right here, we'll go ahead and prove it anyway. All right?